Okay, guys, we are moving on to our next section. So, last section we had talked about congruent triangles and how all of your corresponding sides and all of your corresponding angles had to end up being exactly the same. We're moving on to now what are called similar polygons, which is a kind of the same idea, but it's a little different. So, in similar polygons, your corresponding angles must be congruent. Okay, remember I'm using my shortcut here. So those must be congruent, but your corresponding sides or your corresponding side lengths must be proportionate. Okay. So basically all that means is your angle measurements between the two figures are still going to be congruent to one another, but your side lengths are going to be different. It's almost like you're either shrinking down your original shape or you're making your original shape much larger. Okay, so your side lengths are going to be proportionate here. So from these two figures here, my corresponding angles, you would of course have angle A and angle E being congruent. You'd have angle B and angle F being congruent. Angle C and angle G would be congruent. And angle D would be congruent to angle H. So that aspect has not changed in similar figures. What has changed is how we compare our corresponding sides. So because our corresponding sides are proportionate, we are looking at them as ratios. So when I compare the side length AB, I know it corresponds to the side EF. I'm making it into a ratio. I'm writing it almost like a fraction. And then side BC would correspond to side FG. And side CD would correspond to side GH. And AD corresponds to EH. So we're now writing our side lengths as ratios. So if I had seen, or if I had told you that these were the side lengths on our figures to the left here, then I can use these ratios to write down the actual values of our side lengths here, right? So AB has a length of 8. That's compared to the side EF, which is 4. BC has a side length of 10. That compares to FG, which has a side length of 5. CD has a length of 6. GH has a length of 3. And AD has a length of 8. And EH has a length of 4. Now, all of these aren't necessarily equal, but they have to be, right? They don't look equal right now, but all your side lengths have to be proportionate. So what that means is I need to reduce all of these fractions to make sure that they are in fact going to be proportionate. They're going to be equal, right? So 8 and 4 are both divisible by 4. 8 divided by 4 is 2. 4 divided by 4 is 1. 10 and 5 are both divisible by 5. 10 divided by 5 is 2. 5 divided by 5 is 1. 6 and 3 are both divisible by 3. 6 divided by 3 is 2. 3 divided by 3 is 1. 8 and 4 are both divisible by 4. 8 divided by 4 is 2. 4 divided by 4 is 1. So they are, in fact, all equal. They are all proportionate. And this is your scale factor. So that reduced version of all of your ratios is considered to be your scale factor. So the scale factor is the ratio of the lengths of two corresponding sides. So for your in order for your side lengths to in order for your figures to be similar, all your side lengths all have to reduce down. Your ratios have to reduce down to the same exact scale factor here. Okay, so if I wanted to go back to the end of this and now say, okay, these two figures are going to be similar, we're going to say figure A, B, C, D, and they're similar to being congruent, right? It's not necessarily like they are congruent. They're not the exact same size and shape here, but they're similar, right? This is the symbol for similar. It's kind of like that congruent symbol. You're just taking away the equal sign because they're not congruent, right? They're not equal. Okay, so those are our similar figures here. If we scroll down, or if we look down here, it says practice writing statements of proportionality. We want to go through and we want to actually write our proportions between all of our side lengths. So side AB would be corresponding to side DE. That's our first ratio. That has to be equal to the same ratio between AC and its corresponding side DF. And it has to be the same ratio between the corresponding sides BC and EF. So take a second, go ahead and pause the video right now. Go ahead and list out your corresponding side length ratios for number 2. Okay. On number 2, we want to list our sides according to our similarity statement. So just like a congruent statement, our similarity statement lists the letters in the corresponding order. So when I look at side RS, that's going to correspond to side WV. Right? And when I look at side ST, ST will correspond to VW. And then when I look at side RT, RT is going to correspond to WU. Okay, so those are your ratios for 1 and 2. Okay, you can pause the video again. Go ahead and write your ratios for 3 and 4. Again, pay attention to your similarity statement. Okay, that's the most important piece to tell you which sides are corresponding. So for example, PQ does not correspond to XY in this diagram. So base your ratios off of your similarity statements. Okay, go ahead and pause it and try 3 and 4. Okay, so on number 3, side CD corresponds to side MJ. Side DE corresponds to JK. Side EF corresponds to KL, and side CF will correspond to side ML. Okay, so that is our first set of ratios here. On number 4, again, going off of just the similarity statement alone, PQ would then have to correspond to ZW. Okay, QR would correspond to WX. RS would correspond to XY. And PS would correspond to ZY. So those are similarity statements on 3 and 4. In the example below, we have our similar triangles. It says list the corresponding angles. You can use just the similarity statement to do that, or you can use the diagram here. So you can say angle R will be congruent to angle X. Angle S will be congruent to angle Y, and angle T will be congruent to angle Z. Your ratios of the corresponding sides are what we were doing above, right? So we would say side RS would be corresponding to side XY. Side ST would correspond to side YZ. And side RT would correspond to side XZ. So those are our ratios. And letter C says, are all of the ratios the same? So we're going to actually fill in our side lengths here. So RS has a length of 20. XY has a length of 12. ST has a length of 30. YZ has a length of 18. RT has a length of 25. XZ has a length of 15. So when it says are all the ratios the same, again, as they're written right here, no, they don't look the same, but we still have to reduce them all. 20 and 12 are both divisible by 4. 20 divided by 4 is 5. 12 divided by 4 is 3. 30 and 18 are both divisible by 6. 30 divided by 6 is 5. 18 divided by 6 is 3. And 25 and 15 are both divisible by 5. 25 divided by 5 is 5. 15 divided by 5 is 3. So yes, they all end up becoming the same ratio here. And when it says what is the scale factor again is this reduced version. The scale factor is 5/3 here. Okay. Go ahead and pause. You can go through and you can check on number 6 if these figures are going to be similar. And then we can go over 6 together. But on 6, you just don't need this last figure here, obviously. So go ahead, pause it. Try number 5, write out your ratios, see if they're similar, and tell me your scale factor. Okay, so on number 5, side AB corresponds to side DF, so we would have 3/6. Side BC corresponds to side DE, so we'd have 5/10. And side AC corresponds to side FE, so we'd have 4/8. All of these are going to end up reducing to just 1/2. Okay, since they all reduce down to the same ratio, this is our scale factor. Right, our scale factor is 1/2. And then our similarity statement, I'm going to say triangle ABC. I'm using my similar symbol, is going to be similar to triangle FDE. Okay. The difference between 5 and 6 is when I go and I set up my ratios on 6, right, I'm going to have the ratio of 10/8 because CD corresponds to TU. I'm going to have the ratio of 5/4 because DE corresponds to UV. And now I'm going to have the ratio 12/9.6 because CE corresponds to TV. Now I can reduce the 10/8 to 5/4. The 5/4 doesn't reduce, it just stays as 5/4. But what I don't know is how this could possibly reduce, right? We've never reduced a decimal within a fraction. So what we're going to do is we're going to plug 12 divided by 9.6 into our calculator, right? When I do that, I'm going to get 1.25. So what I need to do is I need to compare this decimal to what I would get for a decimal if I plugged in the calculator 5 divided by 4. If you plug in the 5 divided by 4, you'll also get 1.25. So these are going to end up being all the same, right? They're all equal. So triangle CDE will be similar to triangle TUV, but when it asks for your scale factor, you're always going to give your fraction version of the scale factor. So you're not going to list the scale factor as 1.25. You're going to tell me that it's 5/4. Okay, so go ahead and try number 7. Go ahead, pause the video. You can try number 7. Okay, on number 7, you should find that your scale factor is 4/3. So triangle TUV will be similar to triangle XYZ. Okay, in your next part here, it says in the figure, triangle ABC is similar to triangle DEF. Indicate what type of special segments are shown as dashed lines, then find the value of the variable. We have not talked about the special segments and the names of them. We are going to talk about that eventually. But for right now, we don't necessarily need to name them. I just want you to use your scale factor and your proportions to help us figure out this value of x. And something we just have to keep in mind is, yes, our scale factor will always help us with our side lengths, but it'll also help us with these special segments as well. Those follow the same scale factor. So I'm going to set 30/35 because those are corresponding sides, and I'm going to set x over 28. So I'm using this proportion here to help me solve for x. Now I can cross multiply and divide to get x from here, right? I can multiply 30 times 28 and I can divide it by 35 to get x. Or if you didn't want to use the large numbers here, you could reduce this down to your scale factor, right? 30 and 35 are both divisible by 5. 30 divided by 5 is 6. 35 divided by 5 is 7. And you can cross multiply 6 times 28 and then divide by 7. No matter what you do there, you're still going to end up getting x as 24. Okay, whether you multiply 28 times 30 divided by 35 or whether you multiply 28 times 6 divided by 7, you'll still get x as 24. Okay, on 14, you'd try the same setup. You would have 27 over 36, and you would set that equal to y over 16. And again, you can reduce this. These are both divisible by 9. So you'd have 3 over 4 equals y over 16. And you can cross multiply your smaller numbers, or you can cross multiply and divide by these large numbers. No matter what you do, you're still going to get that y is equal to 12. Okay, so I want you to pause the video. I want you to go to the next page and try out questions 3 through 8. The one thing I will mention is that on these questions, you're still going to use your variable, right? So in this case, we would set QR as y, right? Y over side DE, which is 2. When I set that equal to my other proportion, I can use whatever I need to. We can use PQ compared to CD, so 6 over 3, or we can use PR compared to CE, which is 8 over 4. Either one will give us the same answer because remember, they follow the same scale factor. Okay, so go ahead and pause the video, try numbers 3 through 8. Okay, on number 3, if we cross multiply, divide, we should get y is equal to 4. Number 4, we should get y is equal to 24. Number 5, we should get x is equal to 2. 6, we would get x is equal to 6. 7, we would get x is equal to 20. And 8, we should get x is equal to 16.25. Okay, so those are your answers based on the appropriate proportions. On number 9, it says find the scale factor of DEFG to PQRS. So we can set this up, right? We really have a lot of options. We can use any of these side lengths comparing RQ and SP because those are the values we have, right? So if I used RQ corresponds to FE. So I'm going to take 24 over 12. Right, and that's just going to tell me my scale factor is 2 over 1. Okay, so my scale factor is 2 over 1. It says find the value of x. I'm going to use my scale factor of 2 over 1. QP here, which is x, is going to correspond to ED, which is 36. So I'm going to put this as 36 over x. Okay, and when I have this, I cross multiply and divide. I end up getting that x is equal to 18. Okay. The bottom question here talks about the perimeters. The one thing we have to remember is that our scale factor is going to help us with everything. So our scale factor will help us with side lengths, it'll help us with special segments, and it'll help us with perimeters. So when I say find the scale factor of FGHJK to ABCDE, first off, recognize I'm not asking for it in the traditional sense where I would say this goes on the top and this goes on the bottom. I'm asking for this figure to go on the top and this figure to go on the bottom, which is a little bit opposite of what we have been doing. So number 4, the only side length I have on this small figure is 10. So AB corresponds to FG. So I'm going to put FG on the top, AB on the bottom, and I'm going to reduce to get that my scale factor is 3 over 2. I have to find the value of x, again using my scale factor. X is on my smaller shape, and my smaller shape goes on the bottom of my fraction here. So I put the x on the bottom. X corresponds to this 18. When you cross multiply and divide, you get that x is equal to 12. So 2 times 18 divided by 3. And now it's asking us to find the perimeter of this smaller shape, right? And I don't necessarily feel like going through and finding the side length for BC, finding CD, and finding DE, and then having to add up five sides. So instead, I'm going to use my scale factor to help me find my perimeter. I can take the perimeter on FGHJK by adding up all of these sides. So when I add up 15 plus 9 plus 12 plus 15 plus 18, I'm going to get my perimeter as 69. So I can use this along with my scale factor to find the perimeter of ABCDE. Okay, remember that FGHJK was going on the top here. So I'm keeping 3 halves. I'm putting the perimeter of 69 for FGHJK on the top. And on the bottom, I have the perimeter for ABCDE. And now I'm still going to cross multiply and divide to find that this perimeter is going to end up equaling, what did we get? 47. Okay, so again, scale factor, and it says right at the top of this page, really, this is what this is talking about. Your scale factor helps you find side lengths, special segments, and your perimeter. Basically, anything that has to do with side lengths or just lengths in general on your triangle, your scale factor is the same for all of that. Okay, in the last section, this last problems here, we can set up, again, with the special segment, we can set 16 over x and set that equal to 18 over 27. And we can cross multiply, divide here to find that, let's see, x would equal 27 times 16. We would get that x is equal to 24 in this problem. Okay, on this problem, it's a little different. Okay, because I have I have the same variable, but I have it in 2 different spots. So I'm going to do y minus 1 over 16, and I'm going to set that equal to y over 18, because those are my corresponding sides and pieces here. And I can't cross multiply divide like I've been doing to solve for my variable, so I'm going to cross multiply to solve for this proportion. I have 18 times y minus 1, because I need to remember that those are both going to get multiplied. And I have y times 16 to get 16y. So I need to remember that 18 gets distributed to both the y and the 1 to get 18y minus 18 equals 16y. And then I can just solve for y. I'm going to subtract the 16y to get 2y, and I'm going to add the 18 to get 2y equals 18, which means that I'll find that y is equal to 9. Okay, so we're using our scale factor here again for basically every little piece of information. But if you have the same variable just in 2 different spots, you have to solve your proportion in this sense, kind of with that butterfly process where you're cross multiplying. Okay, so our homework for tonight is page 362 to 363. We're going to do numbers 3 through 25 odd or 3 through 25 all for extra credit. Okay, I do think that first off, learning this with a video might be a little bit more difficult than if I was there in person. So I will stress that make sure you are listening to the whole video, taking your time and going through your practice examples on your own before I'm giving you the answers, because that'll be the most beneficial for you at that point. Okay, so bookwork is due on Monday. When I see you guys, I will be here on Monday, so I'll check that off on Monday.